Hello everyone, we will continue with the unit number 2, 503, that is solid state switching circuits. In the last lecture, we discussed about the switches, electronic switch, transistor action of the transistor, a switching action of the transistor, and how transistor can work as a switch. Now we're starting a new topic, that is multi. It is a one kind of the electronic circuit. It is a kind of the electronic circuit which can generate a non-sinusoidal waves, waves. That is generally square wave, rectangular wave, sawtooth waves. They are all called as a non-sinusoidal waves. So the switching of these circuits will depend upon the positive feedback, operation of the positive feedback. And as shown in the block diagram, we are showing a first stage transistor Q1, second stage transistor Q1. So it is basically a two-stage amplifier. Two-stage amplifier with the output of the one feedback, to the input of the other. That is, we can say this is a positive feedback. So this is the principle of the multi-vibrator is generation. It's generated square wave with the help of the positive feedback. As shown in the figure. See, the output of the first stage is fed to the second, then this input is fed to first stage. So this is called as positive feedback. Whatever the V out we are obtaining, that V out will be fed to the input. See how square waves are generated. That is generally nothing but two-stage amplifier with positive feedback. So it can generate a square wave with the help of the positive feedback. How? Generally, this circuit will operates in the two stable state of the transistor. The two stable state of the transistor are the on state and the off state. On state and off states. And each first amplifier stage will having a feedback. And that feedback is responsible to drive the transistor of the one stage from saturation and the other to the cutoff. So the positive feedback or the feedback is responsible to drive the transistor in the cutoff and saturation. And in this multi-vibrator circuits, at any instant of the time, the one transistor is in cutoff, another is in saturation. Or we can say that one transistor is on, another is off. One transistor is on, another is off. So we can say that feedback is responsible to change the states. And after the certain time of the interval, that is controlled by the circuit conditions, the action is reverse. It means the saturated stage is driven to the cutoff, and the cutoff stage is driven to the saturation. And you can take the output from any one of the transistor, and the output across any transistor is either rectangular or square wave. That is depending on the circuit time constant. See, the block diagram will shown over here, that is two-stage amplifier with the positive feedback, Suppose the output is taken across the transistor Q2. If we're taking output is from the transistor Q2, that is, we are taking output from this terminals or output from this transistor Q2, and then we can say that at any particular instant of the time, any one of the transistors is on, and that will be conduct, and its collector current is at saturation. As shown in the figure. So after this time, certain time of the interval, the transistor which is at saturation, that is Q2, is driven to the cutoff, and it's time to turn on the Q1. So we can say that now after the certain time of the interval, the output current of the transistor that was saturation, now it becomes cutoff, or it will become a leakage current, that is IC. Then we can say that the circuit will remains in this condition. That is a Q2 is in cutoff and Q1 is in saturation. That is so denoted by the curve dE, and that is dependent upon the circuit time constant. And after the certain time of the interval, again this condition will be arise, in which we can say is that the Q2 will be saturation and Q1 will be at cutoff. So this way, the square wave will be generated, and width of this square wave can changes by changing the time constant. That is value of resistors and capacitors. So this is the principle or working of the multi vibrators. So we can say is that is having a two stage. On the basis of that, it has three types of the multivibrators. Depending on the on and off of the transistor states. We know very well the principle in the earlier, at any particular instance, one transistor is on, another is off, depending upon the certain time, depending on the circuit components, that is resistor and capacitor, the condition is reversed. That means the conducting stage will suddenly the cutoff and non-conducting stage will start to conduct. So on the basis of that, there will be possible states of the multivibrators. That is, the first stage is either on or off. The second state, the Q2 is on and Q1 is off. And depending on the manner in which the two stages interchange their states, the multivibrators are classified as S-stable multivibrator. In which S-stable multivibrator means, that means it can generate square wave. By its own. That's why we can say that it automatically altered between two states. Automatically will be altered between two stages, from cutoff to saturation, cutoff to saturation, saturation to cutoff, depending upon the circuit time constant. That's why we can say that it is a free running multivibrator. In the stable multivibrator, no state is stable. A monostable multivibrator, that is also called as a one-shot multivibrator. And we can say that in one-shot multivibrator, it's one stage stable state, another one is a quasi-stable state. So it's required external triggering pulse to change the states. Or you can say is that the application of that pulse triggering will be giving the quasi state to on for the certain time of the period. That depends upon the period value of the R and C. After that effect, the effect of the triggering pulse will be over. Then it will return to its original states. So by giving the each and every time, we are giving an external triggering pulse, and we can say that the output will be generated, or square wave will be generated. So we can say that monostable multivibrator will produce a single output pulse for each input trigger pulse. So it is called as a one-shot multivibrator. In which one state is stable, another one is a quasi-stable. The third type of the multivibrator is a bistable multivibrator. In which if both states are stable, and it requires the external triggering pulse to change the operation from one state to other states. It means we can say that the one pulse will generate the half cycle, other pulse will generate the next half cycle. That's why it is called as a flip-flop multi-vibrator, because of the two possible step it can be assumed. So, depending on its states, there will be three types of the multivibrators are there. The first one is a stable or a free running multivibrator. Second is a monostable or a one shot multivibrator. And the third one is a bistable or a free flow multivibrator. In a stable multivibrators, there will be no stable state. It can continuously generate the square wave. That's why it is called as a free running multivibrator. A monostable will require a one external triggering pulse, or it can generate the single output pulse for the input triggering pulse. That's why it is called as a one shot multivibrator, whereby stable will require each in the one triggering pulse to generate the half cycle. The next triggering pulse will give you the next half cycle. That's why it is called as a fifth law of multi-vibrator. So in the next lecture, we are discussing in the detail discuss about the stable, monostable, and bistable multi-vibrator. Thank you.